Hi there, I'm Mohammad Milza Mehmet Fauzi, and I'm going to explain part B for question 1. Suppose you are a loan officer for a bank, a startup company has qualified for a loan, you are pondering various proposals for repayment. A lump sum of 250,000 ringgit Malaysia, 5 years hence, how much will you lend if your required rate of return is at percent compounded annually? So here using the formula of PV equal to S times 1 over 1 plus I to the power of n, where S is the future value, I is interest rate, and n is pay periods. The S value is given in the question, which is 250,000, uh, and I is also given, which is 8%, and n also given, which is 5%. Using the data, we insert into the formula when we have for question 1A1, which is RM 170,145 ringgit and 80 cents. For the question 2% compounded annually. So we same goes like here, but then we change the value of I, which is 12%. So we got 141,856 ringgit and 70 cents. So repeat the number 1, but assume the interest rates are compounded semi-annually. So here semi-annually, which mean the interest rate and the pay period gonna be changed, where in the interest we divide it by 2 because it's semi-annually, and pay period we double it by 2. So here we got for the question 1B1. So the rate of return I is 4% and n is 10. So insert into the formula and we have the value of RM 168,891 ringgit and 4 cents. Same goes to the question B2. The interest rate is changed to 12%. So we changed we divided the interest rate by 2, and the period is 5, which times by 2 is equal to 10, and insert the value we have into the formula, and we have for question 1B2 is RM 139,598 ringgit and 69 cents. For the question C is suppose the loan is to be paid full by equal payments of 50,000, and at the end of each year of the next 5 years, how much will you lend if your required rate of return is at percent compounded annually? So here we will use a different formula, which is PVA equal to CF times 1 over I times 1 minus 1 over 1 plus I to power of n, where CF is amount of annuity payments, and the I and n, I is interest, n is pay period. So CF here we given by 50,000, and we insert into the formula, and we have the answer for question 1 C1 is 199,635 ringgit and 50 cents. Same goes to the question 2. Just insert everything and you have 180,238 ringgit and 81 cents. Thank you.
Okay, for part B, which is of the calculation, I am in charge of doing question 2. So, first of all, for the sub-question A, we will have to find out the NPV value for 10%, 12% and 14%. Alright, the method in order to solve this question is to find out the value for each percentage of NPV as per according to the PVIFA table of 5 years. Whenever we get that particular value, we will times by the amount of savings, and this particular number, which is discounted cash flow, will be used to subtract the investment value. So from here, for NPV of 10%, the value is 1860. For NPV of 12%, the value is 0. And for NPV of 14%, the value is negative 1717. The IRR value for sub-question B is to be computed. And the IRR value can be determined by dividing the investment value with the savings. So as per calculation, the IRR value is 3.6048. Now, when this number is obtained, the PVIFA table of 5 years is referred to again, and from here, it can be deduced that the IRR value will fall under 12%. For sub-question C, the answer is the company will actually accept the discount rate for 10% and 12%. However, for 14%, the NPV value is negative, therefore the company will not accept. And for sub-question D, since the IRR is more than the desired rate of return, and following to the IRR rule, the project will be accepted. Thank you.
For question 3, part B, it has a cost of each machine, which is 14,000, and expected to have salvage value at the end of a 4-year useful life. And company L is requiring rate of return, which is 12%. And we can see in this table of annual after-tax cash savings for each machine, and it has 3 questions which require to calculate the payback period for each machine and the NPV value for each machine, and which machine should be purchased. For the payback period for machine A, we use this equation, which is payback period is equal to machine cost and annual cash flow. We use this equation since the annual cash flow is equal every year. So payback period equal to 14,000 over 5,000, and we get 2.8 years of payback period for machine A. While for machine B, we calculated the cumulative annual cash flow, or which is known also collected payback. And from this table, we can see that the collected payback on the 4th year is equal, on the 2nd year is equal to the cost of the machine, which is 14,000. So the payback period for machine B is equal to 2 years. For the NPV each machine, we use this equation for each year for both of these machine, and we calculate the total of present value, and we get for machine A is 15,187 ringgit, while for machine B we get 16,044 ringgit. And to calculate the net present value, we minus it with the initial cost of machine, which is 14,000, and we get for machine A is ringgit Malaysia 1,187, while for machine B we get 2,044 ringgit. And which machine should be purchased? From this table, we can see the difference between both machine A and machine B, and the machine should be purchased is machine B, since the payback period is shorter than machine A, and it has a big return than the required rate of return.